Before going forward, we need to define what high availability is and which components of it we'll focus on in this particular presentation. Obviously, a service is available only when the users can perform the transactions that they want. Any other definition from the user perspective is totally meaningless. It doesn't help you if the server is available but the application is crashing, or if the application and server are okay but the network is down, and so on and so on. So there are at least three components in this picture. Number one, the application. The application and all the related components like the database have to be available or there will be no service. The hardware. Obviously, servers, storage, and so on have to be up and running, and the network. In the network part, we first require connectivity, and second, we require working network services, for example, DNS. In the past, we've tried to solve the high availability problem by replicating everything. So you would have the tandem mini mainframes that would be totally redundant inside, and they would have an operating system that would be totally redundant. Then you would have a network that would be fully redundant, and so on and so on. That works sometimes. It's also pretty complex and really expensive. So the new wave of application architectures is recommending that we don't focus so much on the pure availability, but more on resilience to failures. Because after all, we can never control the first hop between the client and the network. If the client is using an iPhone and there is no 3G signal, the client won't be able to access the service anyway. So instead of focusing on traditional high availability, the new applications are trying to do graceful degradation, and they try to be resilient to failure. Even if I don't have network connectivity, maybe there is something I can do for my user locally. If the database is down, maybe there is some read-only state that I can still show to the users. If the primary database server is down, I still have the database. It is only read-only, but still, the users can view their data. They just can't update it. Modern high availability is way more than redundant hardware. It goes deep into the application architecture, where the application developer should start thinking about implementing mechanisms that will give the users the most they can get based on what the status of individual components is. Now, if the application is very simplistic and runs on a single server, then from the networking perspective, DNS services are unchanged. Layer 2 hasn't been changed by IPv6 at all. IPv6 is running over the same Ethernet as IPv4. There are some new first hop router protocols, and we'll go through those. Core network hasn't changed much. As I said before, OSPF version 3 is new. Apart from that, the routing protocols haven't changed much. Same with multi-homing. Even though they were promising us all these perfect solutions to the multi-homing problem, they're still not there. I mean, IPv6 from the multi-homing perspective is totally identical to IPv4. The only addition that we got in the recent years are more options, and one of them, Lisp, is what I will also cover at the end of this presentation. However, you have to keep in mind that most operations people are no longer used to running two protocol stacks in the network. For the old timers, it was a given. We were running IP, IPX, DECnet, AppleTalk, whatever, in our networks, and we knew how to run a multi-protocol network. And then all these other protocols died, and for the last 10 to 15 years, we were running a single protocol, IP-only networks. The knowledge that's needed to run multi-protocol networks is no longer present, and the operations teams will have to regain that knowledge. And that's where the old-timers will be extremely helpful. For example, you might deploy IPv6 in your network and you forget to include IPv6 access lists. Or you deploy IPv6 on a Linux host and you forget to add IP6 tables. Or you deploy IPv6 on your routers and you forget to add IPv6 access group on VTY. Because people are still not used to think in multi-protocol environment. Even more, even though we were running multi-protocol networks 20 years ago, at no time was the same application running over multiple protocols simultaneously. And we never had a situation where two network protocols would be more or less of equal importance or priority. That's another aspect that most of us haven't mastered yet. First, we have a dual stack network. And second, the same application could run over IPv4 or over IPv6. And the situation might change dynamically. So one connection could be over IPv4, the next connection would be over IPv6. And this introduces another layer of complexity and non-determinism. And both of them are enemies of high availability. Now, moving forward to a bit more complex application stacks,